Hello, this is OtakuSolutions. This time, some of you who bought BipedPlus said converting isn't going as planned. So I'll focus a bit more on the Full Convert FBX side and share some converting analysis tips. I work in both video and games, and game industry rigs tend to share similar traits. If you look at the rigging, the big base is usually biped. It's biped-based, and around the main bones you'll also find twist bones and extra bones. Extra bones attached to the body are often built with a relatively simple structure. They often skip a complex bone setup so they can use springs later. In my experience, most game studios were set up this way. That's why I thought BipedPlus FBX converting could still go reasonably smoothly. The part to focus on is mainly the body, the rest is relatively easy. In Maya rigs or other pipelines, they often custom set up everything from the skirt on. Luckily, extra bones in 3ds Max game rigs are mostly simple structures. So just creating and placing the bones is enough. Bottom line, just analyze the main body well. Biped is mostly similar, the part to watch is twist. You usually check schematic view, but that can be hard to read. Instead of schematic view, let's check sort by hierarchy in the layer window. Let's start by analyzing the legs. I think it'll be easier to go through this with weight. Thigh weight is placed toward the end, and in BipedPlus Seg that belongs to number 3. This kind of setup mixes biped, custom bones, and weight, and some studios do this to cut bone count. With BipedPlus style, or the way I rig, clarity matters more than bone count. So I tend to set up things as intuitively as possible, like 1, 2, 3. In this example, they set thigh like this. I split thigh as intuitively as I can. If you use 3, it would be like 1, 2, 3. Just jot it down like this and understand the structure. Next, let's check calf. The biped calf bone is at the start, and calf twist weight is assigned toward the end. They also set up this way to reduce bone count. I think biped calf can go into Seg 1. I'll put calf twist as Seg 3. The name doesn't have to be exact. You might ask, shouldn't calf twist be number 2? But it's 3, because we'll set our Seg count to 3, and the weight sits at the end. In this rig, there's no center weight for Seg 2. That's fine. Let's proceed this way for now. You don't really need to do the right side. The right side has the same structure. Checking with weight is faster than pulling bones one by one. Here too, there's a biped arm and 2 twists. Probably the same pattern. Right, here's number 3. So what happens with this? Biped upper arm is Seg 3. Twist 1 is Seg 2. Twist 2 is Seg 3. If you also check the weight values for 1, 2, and 3, that's perfect. Studios often set it up this way to reduce bone count in games. But with this setup, you can hit limits when using stretching. So for now I'll memo it as Seg 1 through 3 like this, and swap it later. ForeArm is a similar setup to calf. Biped ForeArm is 1, and twist ForeArm is 3. It's mostly this pattern. Legs and arms look the same, right? The weight here should look stronger, but right now it's a bit light. But this is the correct weight. It just looks that way because there are fewer edges. Analyzing like this before converting is really important. That's it for the analysis. Let's convert based on this data. But wait a second. BipedPlus just got a new feature. When you lay down a biped in figure mode, you can save a .fig file, right? It's FBX based, but if you also add .fig, the result gets much closer to the original. And convert quality goes up. So this time I'll save the .fig data. Once that's saved, let's jump right in. I'll run the FBX work with the data we just analyzed. I've already exported the character FBX and the .fig data. Please select it and find. By the way, this character is Beto from Genshin Impact. Put the .fig data in here and run FBX import. Import is done. You can see it came in correctly. With FBX analysis, we check the expected keys and joint count. Looks good. We'll go with 3 leg links. No reverse joint legs. It's a human, after all. I'll do twist with 3 as well. That should be enough. Now it's step 3. This part is the most important. In the earlier step, we already analyzed where each weight belongs. Auto analysis runs in a first and second pass, but even that isn't perfect. Let's take a look. Looking at upper arm, the analysis showed biped weight was heavily concentrated on this side. So it should be assigned to Seg 3. It's split into 1, 2, and 3. I'll right-click here and set upper arm to Seg 3. This side is already set to 3. Change the existing item to skip. That means we're replacing it with this. Click yes. Then this side gets set to skip. It was 2 earlier. Let's check again. Assign this one too, and set it straight to Seg 3. It's assigned like this. Twist 1 is correct. From what I remember, that's right. 1 is correct, but 2 has a problem, so I'll set it to 2. I'll set this to 2 as well. It can be confusing at first. Once you get used to it, it gets much easier. Now let's search for forearm. Biped forearm was concentrated on 1. Forearm twist weight was concentrated on 3. What we're doing now is a temporary rename to reshape the skinning data the way we want. 1 is correct. Searching just 4 might be better. This isn't it. We haven't assigned it yet. Assign it. This one is 3. There we go. In this setup, it's only start and end. And unfortunately, this rig's forearm doesn't have weight too. We can fill that in later. For now, 1 and 3 are correct. I ran through thigh the same way, quickly. Same structure here, and biped thigh is 1. If you just watch this part, the rest goes smoothly. Twist 2 is seg 2. Place them as 1, 2, 3, following the notes from earlier. Nice. We should check the knee too. Biped is the start, number 1, and twist is 3. Same as forearm. Done. 1 and 3. It's a bit tricky, but this is the last part. Spine, neck, and head are landing on seg just fine. They need to sit on seg because of stretching and squash. The values seem to have come in correctly now. Honestly, for most of it, you only need to watch the second analysis table. The remaining picked parts are the replacement sections we fixed by hand. Extra bones have no matching bones in BipedPlus, so just leave them. They'll be placed as is. Move on to step 4 and check in at point in the target joints. This part looks fine. This is because unassigned bones will need to be parented to the new hierarchy later. So this part saves the current hierarchy. Looks good. Now save the skin. This'll take a little time. We'll save hierarchy data too, then check if rename went through. Rename looks correct. The part that was originally biped thigh changed to 3. We temporarily renamed it save the skinning data. Now we save. Now our rigging module will import. To avoid name clashes, I'll prefix existing items with legacy. Once that changes, there are no duplicate names. Now we go to step 7. Now I'll import the BipedPlus module using the data we set earlier. Import is done. Thanks to the .fig we added in step 1, it's almost identical to the original we first saw. There we go. And if you look at the tool, because we added .fig data earlier, you can see it switched to Biped Classic. There were some unverified bones earlier, right? Those bones need to be parented to the original BipedPlus hierarchy. I'll parent them now. The outfit was created correctly. The skirt and headband are there. Now we load skin. Loading. This'll take a little time. Skin data loaded correctly. I'll clean up the legacy nodes too. That notice earlier means you should clean up the temp data used for saving. We're done with it, so I'll delete the unused items. Once those are gone, we're finished. Let's check the state with Picker. If you look in World, you can see it loaded correctly. This looks pretty good. Again, this character is Beto from Genshin Impact. This is an actual client case, so we asked permission and used it briefly as an example in this video. Scale applies well too. See, it takes it like this. Stretching looks like it's working now, but with this structure there's still a problem that isn't solved. Thigh has 3 segs right now, so the arc should form nicely. But on parts with only 2 bones, like the knee, it may not take as intended. Still, the skinning bones are solid, so if you distribute weight well, you can make a clean arc. Whether you use Skin Layer Studio or default 3ds Max skinning, just make a clean arc. But don't worry, the important thing is whether the base is set correctly. Fixing weight isn't that hard. The skirt is still attached as before, and it's very clean. Scale should apply well too. That's it for walking through a convert on a different character. If you get stuck along the way, email us anytime through the website. Unlike other developer tools, fixes will come through quickly. We think the real start is after the tool has been released. Getting feedback and improving fast matters a lot more, I think. No tool is perfect from the start, and that path is how it can get closer to perfect. If you get stuck, don't sit with it alone. Reach out anytime by email, open chat, or messenger. This lesson was a bit of a tough part. Thanks for watching to the end. That's it from Otaku Solutions. Thank you.